Okay, this is GCSE exam paper for the Pearson Edexcel International Physics Paper 1. This was the paper that they gave in summer of 2023. Okay, so I've got the mark scheme and I've linked it with model answers on the script. Okay, we used it in our school as a mock exam with a minor alteration. So I'll explain when I get there. So we used it just this January, so I've changed the date. Make sure when you go into the exam that you are aware that they give you a complete equation booklet. I stapled it to the back of the paper. And you need to take in a protractor in some of the exams in case you need to measure angles. In this particular exam, you didn't need a protractor, but for physics exams, generally you need a ruler, a calculator, and a protractor. Okay. All right. So this is the original equation sheet that they gave to students before COVID, and then during COVID, they then produced this equation booklet. So this is the one from 2023. Someone told me they've altered it slightly, but I haven't seen. You'd have to go to the Edexcel website to take a look if you want to get the exact one, but this is the one we used for the January mocks. So they go in order of the topics. Topic 1 is forces and motion, and they give you all of these equations. So the original list of equations was much narrower, and then electricity. Obviously, you need to know how to use these equations, so you need to be familiar with them. And I had one student who copied down an equation wrong, put the numbers in, of course, lost all the marks. So be careful the way you use it and really become familiar with these equations before you go in. So waves has 4 equations. Energy resources, energy transfers. I think in this equation, they are using the efficiency equation in one of the questions and with the Sankey diagram. Solids, liquids, gases, density, pressure, pressure difference, pressure temperature ratio being constant, and pressure times volume are the equations. Now you'll notice that topics 6 and 7 don't have equations. So topic 6 is magnetism and electromagnetism. Topic 7 is radioactivity. Topic 8 is astrophysics. Okay, in the mock exam, we didn't cover the last 2 topics, so I replaced any questions with that. This final equation sheet, which is in the same booklet, is for students doing Physics IGCSE only, and these are the extra equations that you need for the bit that's not in double science, and these equations will only be used in paper 2. So if you're doing double science, you do not need to worry about the equations. But it looks like they've produced one equation booklet which can be used for paper 2 as well as paper 1. So if that's exactly the same this summer, the format of the equation sheet, I'm not sure. You'd have to wait and see. Okay, so question 1, it's about the electromagnetic spectrum, and they want you to look at the statements and place 3 ticks to show which statements are correct. Well, you can see which statements are correct. You'll get -1 for any line that's incorrect. So a lot of students, I noticed, they tick this, the first one, that electromagnetic waves are longitudinal. Of course, they're not. They're transverse. And then later on, there was a question about electromagnetic waves, and they'd taken the error from question 1 and then got it wrong again in the question which came later, which was also on waves. Okay, so electromagnetic waves travel through space, empty space, yeah. So free space, they mean in a vacuum. This one is correct, and that's at the speed of light. Okay, so radio waves are the longest wavelength in the spectrum, and the shortest wavelengths are gamma rays. Okay, so it says X-rays have the highest frequency. Well, they don't. The gamma rays do. Okay, so gamma rays are natural, X-rays are man-made, and all electromagnetic waves transfer energy. Okay, so these three highlighted ones are the ones that are the correct ones. So the fifth one, it says all electromagnetic waves can cause cancer. Well, the fact that it says all, yeah, obviously they don't all have a risk of creating cancer. It's only the high energy ionization energy ones which produce ionization energy, so that means gamma rays, X-rays, are the ones that can cause cancer as a consequence. Okay, so the next bit goes to uses, and this is very common. So electromagnetic waves can be useful and can also be harmful, and they're concentrating firstly on microwaves. So the first part is they want you to have a use and a harmful effect of microwaves. Well, then obviously most people got heating food. Remember, it's not cooking food, it's basically just a heating of food. So cooking technically is not the correct term, it's heating. And a harmful effect is internal heating. Yeah, it's not the skin, it actually goes deeper. So you need to put internal heating of body tissue. Okay, it's not quite the same as burning the skin. The burning the skin will be with normal heat. Microwaves go deeper. That's why heating food is faster in a microwave, because it doesn't have to go through by conduction. It goes and excites water molecules. Okay, so you can have internal heating of your body tissue if you're exposed to microwaves. Okay. So then the second one they want you to look at is gamma rays. So gamma rays are the highest frequency electromagnetic waves. So when you're looking at gamma rays, you should mention that it's used for sterilization of food or medical equipment. Okay, I would put medical equipment because sterilizing food, they do that. So they irradiate food, yeah, and that kills the bacteria or any microbes on it, so it increases shelf life. Okay, but I think this is the best answer to give, the medical equipment one. Okay, and then a harmful effect is due to its ionization ability, it can lead to cell mutation, and of course that the mutation of cells can also be a risk of cancer, I suppose, so, or birth defects in the next generation. So these are alternatives, and you have to look at the mark scheme. You can put that gamma rays can also kill healthy cells, yeah? And there are many alternatives to this one. So if you look at the mark scheme for alternatives, microwaves would be communication or radar, yeah? And one example of using radar is by locating rain clouds, and for alternatives for gamma rays, cancer treatment, so you can have a positive treatment in terms of trying to kill the cancer cells, but that's called radiotherapy, and medical tracing can also be a medical use. Okay, so here is the mark scheme. The first bit is the tick boxes from the first page, and then the uses, valid uses and valid harmful effects, and you can see the notes that they put in the second column, so you can stop the video and have a look and see if what you've written has been included. Okay. This was a question I had to remove because my students haven't done astrophysics, so if you're actually looking at the summer of 2023 paper and this question's in there, you can still look at the mark scheme. So I haven't actually included the question in the paper for our students, but if you've got a paper and you want to use this video to correct your own, this is question 2 on the astrophysics question, 7 marker. Okay, so feel free to stop the video if you did this question and you're from a different school. Remember to like, share the video with your friends so more students get to benefit from the model answers I'm putting out there. Question 2 that I replaced is this one. And this one is to do with a filament lamp and how the filament lamp, the current in it changes with voltage. So that's the aim of the investigations, to show how the voltage affects the current in a filament lamp. A filament is a tiny little wire made of tungsten, which has a high melting point, which is why they use tungsten in the old-fashioned filament lamps. And they're great for GCSE questions because when you heat them, they produce light and they get white hot without melting the wire. Okay. All right, so you need to vary the voltage, and a lot of students forgot to include a way of varying the voltage. So you need obviously a power supply, yeah, an ammeter, and a voltmeter across the bulb as your main measuring instruments, and you also need, of course, the bulb. So the 4 I've circled get you 1 mark, and of course then you get another mark for putting the ammeter in a correct place. Ammeter must be in series and the voltmeter must be in parallel, so that's 3 marked. If you've got the correct symbols for all of the 4 I've circled, you get 1 mark. If you put the ammeter in series with the bulb, you get 2 marks. And if you put a voltmeter in parallel with the lamp or the bulb, you get 3 marks. And then the 4th mark is having a way of varying the power supply or the voltage. Okay, so I've used a variable resistor in series with a battery. Okay, now I wouldn't use a cell, but they would allow you to put a cell here, just to be kind to you so you don't lose all your marks. But a cell is only going to produce maybe about 1.5 volts maximum, so you're not going to be able to adjust the voltage to the full operating voltage of the filament lamp. Usually when I do this with students, I use a 12-volt bulb, and therefore they can go all the way up to 12 volts. In this case, they've gone up to 8 volts, and they've measured the corresponding current in amps. Okay? You can see that it's curving, it's not a straight line graph. And you can see that there's, at 7.2 volts, they're interested in the current for a question that comes up. So they're giving you the data and they say describe the relationship between the current and voltage shown in the graph. Well, the current increases as the voltage increases. That will give you 1 mark, and then further detail, yeah, about the fact that it's not a linear relationship. Any of statements like the ones I've written will get you the 2nd more detail mark. Remember, to get full marks in the exam, you need depth, detail, and clarity. So if you're putting things in depth with detail and clarity, then you'll get marks. If there's a lack of clarity, if you use the wrong technical terms, you can lose marks. Okay, so it's not a linear relationship, it's a curve. So it has a decreasing gradient, and the current increases, but it's increasing at a decreasing rate. So these are very clear ways of getting the 2nd mark. Okay, so language seems to be a bigger barrier to getting the marks for most of my students who are studying in a 2nd language than the mathematics part, which is much easier for students to get the full marks on. Now here's an equation that you need to use. They're giving you this equation on your equation sheet, yeah? And they do accept the symbols, but you can see the way I've drawn your attention to the symbols referring to the words. Technically, in physics, you should really use words for equations. That's the definition in physics, is usually with a word equation. Okay, but the IGCSE seems to accept the correct symbols, the common symbols. Remember, current is always I, which is the one that students often forget. Now, obviously, if they're going to give you the full list of formulae, they may not give you questions like this where you have to state the formula and get 1 mark. because obviously you can choose it from the list. So they may change the style of the questions somewhat if they're giving you all of the formulae that I showed you at the beginning of this run through. It then says use the graph, which we looked at before, to determine the resistance of the filament lamp when the voltage across the lamp is 7.2 volts. So you need to show this the way I did on your graph at 7.2 volts to show that the current is 2.40 amps. And at that point on the graph, then the resistance will be equal to 7.2 over 2.4. Both values are given to two significant figures. So your final answer should also be given to two significant figures. Okay? That's important that you realize why you put the decimal place in there. The 0 after the 3 is significant because it shows that you know why you're giving the decimal place. Okay? Now if you look at the graph, you'll see that the steepness is decreasing and the voltage is on the x-axis, currents on the y-axis. So as the voltage increases, the current is increasing at a decreasing rate. So as it does that, it's because the resistance gets higher as you put more energy into the bulb. It gets hotter, and as it gets hotter, you have more lattice vibrations which interfere with the electron flow. It creates some additional resistance in the material. So as the current goes higher, it tries to go in line with the voltage. Initially, it's linear, and then it kind of goes less in line with the voltage, and that's because of the increased resistance at higher voltages. Now, they haven't asked about that, but that's a common question to go through as well. So here is the mark scheme. So if you want to stop it and see the alternative ways of what they will accept, which I went through, the circuit symbols, and then the mathematical part and the relationship between the current and voltage. Okay, so you have to practice using these mark schemes to show the kind of key terms that you must be familiar with if you want to speak the language of the examiner. That's 2 questions done, and then we're going to go through question 3, which looks like it's again using electrical energy, power, and then fuse rating. There it is. It's going to be on fuse ratings. It's just the way I've put the paper together in this PDF. I think it was back to back, so it's two-sided. So question 2 and 3 came together, and here's the question. So family has a television set. The television set has a low power mode called standby. Okay, so low power mode called standby. It's when it's basically not being used at its full operating voltage. When on standby, it says the power rating of the television set to two significant figures is 0.27 watts. So that's how much power it uses on standby mode. And then they want you to calculate the energy transferred to the television in 12 hours. So 12 hours is 43,200 seconds. So you get 1 mark for being able to work out why it's 43,200, which is 12 times 60 times 60. Yeah? So you have to multiply by time, because energy is power times time. Energy in joules is power in watts multiplied by time in seconds. So if you forget to change the units, they won't penalize you completely, but you will lose some marks. All right, so we multiply the power by the time in seconds, and you'll get 11,664 on a calculator if you keep it to 5 significant figures. But really, you should round it up to 2 or 3 significant figures. I'm saying 2 or 3 because time in seconds is 43,200, which is 3 significant figures. However, 12 hours, which is the time they gave you, is 2 significant figures. So it's probably more correct to round it up to 12,000. All right, then it says, in normal use, the current in the television is 0.31 amps. Now remember before, standby was 0.27 amps, so it goes, it's 0.27 watts. So the current is now going, they're talking about the current now, sorry, before they were talking about power. So now they're talking about current being 0.31 amps, again to two significant figures. That's the accuracy they're talking about. And they want you to explain how a fuse works to protect the television set if there is a fault. Now, the fuse doesn't just protect the television, the fuse is crucial for fire prevention, because if the fuse wasn't there and didn't do its job, then the current would keep on flowing and the cable may be overheating itself, and the cable may be touching some soft material like carpets or whatever, and it can lead to a fire if you don't fit the correct fuse. So if there is a fault, the current increases, or a lot of my students put surges above the fuse rating, the value of the fuse that you've got in the plug. When this happens, the fuse wire melts. So that'll give you a second mark. Alternative, you could put it breaks, or a technical way of saying it is it blows, which is what electricians often say. The fuse is blown means that it's melted. It's broken the circuit. So the third mark is when this happens, the circuit is incomplete or broken. Then the device becomes isolated. So it's safe. And this protects the TV and protects the people in the house as well. Okay. All right, so that's how fuses work. I saw a lot of my students put surges, so I was wondering, for a mock, whether students had gone and done lots of revision and had come across some past paper questions, including this one. So remember, the mock is really a chance for you to practice the timing and also what exam conditions feel like. So one of my students admitted to having seen one of the questions in the paper. So if one person's seen it, then of course other students may have already also seen some of it. Now it says in the final part of this question, 8-mark question, explain why a 13 amp fuse is not an appropriate choice of fuse to use in the plug of this television set. Now remember, this television set is using 0.31 amps under normal operating conditions. So what you got to do, what you got to say is that 13 amps is much higher than the current the TV uses normally. So if the current increases due to a fault, it may not exceed 13 amps. So if you put a 13 amp fuse in and a fault occurs, the current may increase, but not enough to blow the fuse. So if the fuse doesn't blow or melt, the TV or the cable could overheat, causing a fire. Okay? So remember, fire is the main thing you want to prevent. So it is crucial that you know how to put the correct fuse in for the appliance that you're talking about. So I'm going to stop the video there. If you found it useful, like it, share it with your friends who've done this paper, or if you think that it will be useful for students in your class. And make sure you've subscribed if you haven't done so already, and you'll then be notified if you hit the bell notification of when I put the next part up. So this is part 1. We did 3 questions. I'm going to have a little break and then come back to it. All right, thanks for watching. See you in the next video.